Hi everyone. Of course, as usual, I'll be doing a YouTube video. In today's YouTube video, I will not be talking about quick labs. I'll be doing a soft introduction to Linux. Linux has a lot of versions. Before I go on, my name is George. I'm a full stack developer, Flask developer, and also an avid GCP cloud professional. Okay, so I'll be using this opportunity to introduce us to Linux. The flavor which I use is Ubuntu. There are much more flavors out there, but basically just slight differences in between the different flavors, but generally whatever is done here can also be done in any other flavor of Ubuntu of Linux that you decide to use. Okay, first of all, let's assume you have installed your Linux Ubuntu. You could do boot with the Windows, or you could just install only Ubuntu. Now, the thing about dual booting with Windows is that Windows has several functionalities, if I will call it that, that kind of prevents you from running it alongside or installing it alongside Ubuntu, or installing Ubuntu alongside Windows. Of course, you need to check online for documentation that will help you go through that. But the one that quickly comes to my memory is the fast boot. We have fast boot where Windows will cache the current state of your Windows machine, and then of course you could quickly just boot from there. So that has to be switched off, and you might need to switch off use signed kernel, but I know Ubuntu kernels are signed and so it should work. So those are the two things I basically remember that you will need to switch off if you want to do boot with Windows. If you don't want to, then you can basically just wipe your Windows and go ahead. I deal boot with Windows, and I will show you this. Okay, so this is my Ubuntu desktop. You see here, all of this is my Ubuntu desktop. My desktop, we have various workspaces, same as on Windows, where we can use various desktop environments to carry out various tasks, and we won't be having clashes between them. Okay, so let me show you. Okay, all right, so let's go to, okay, so this is one, this is the second one, this is the second one, this is the second one. In this environment, you see there's nothing here. It's the same way on Windows. I could bring up an application here, and of course that application will only be seen on this particular desktop. So let me make this so that it's always visible on any of the workspaces that I am on. Okay, so that's another workspace. All right, so it's there. Okay, here let's use the second workspace, and to get to this workspace you simply just hit your Windows key on your keyboard, and your workspaces are here. Okay, all right, so that is that about workspaces. Okay, so let me bring up my terminal here. Okay, this is my terminal, and of course I would do several things here, which of course I'll show you how it's done when using the graphical user interface. Okay, so basically what do we do when we get onto our systems? Okay, we either searching for files, or we are trying to create folders or create files, launching programs, and downloading applications or programs or files off the net. So let's talk about file handling and how operations on our system. Now on Ubuntu, the file application, the program that handles all file operations. Of course, take note that on Linux, files can refer to both folders and ordinary files. So when I say file, I could also be referring to a folder. that is also referenced, also talked about as a file. Okay, so let's look at the file operations folder, applications on Ubuntu. It is called the Nautilus. Okay, so let me bring that one up. All right, so it's gone into the other workspace. You can see that we've gone back here. Okay, so let me close all this. Sorry about that. Okay, so this is Nautilus. No, that's not Nautilus. Let me bring that up. Okay, this is Nautilus. Okay, so let me bring it in a bit. All right, so that's Nautilus as we refer to it on Ubuntu. We have Pacman, there's so many different documents handling applications. Okay, so on Windows, you have Windows File Explorer. Here we have Nautilus. Okay, so if you look carefully, you see all the areas in our system that we can go to. Now we are in the home folder. We have the desktop, which is here, which is this area here. You see it here. Okay, we have documents area where all the documents for myself, George, are kept. We have downloads folder. We have the music folder. We have the pictures folder. We have the videos. We have the trash. Now these folders you see here are created automatically on any standard Linux system. On virtual machines in the cloud, you will usually not have this. In fact, if you don't want to have these folders, there's a configuration file you can change, and it will not create these folders either for you or for any new user. Okay, so at times when you run virtual machines in the cloud, you will discover that some of these folders might be missing as you use your terminal to navigate. That's because in that case, we don't need some of these folders there, and so that configuration file has been altered, and the system has been told not to create these folders. But normally on the desktop, you would have these folders. They are basic folders. Windows has a lot more. Okay, so that's one side to it. Now, the other thing that will get you to really understand and be able to navigate around your Linux environment is to truly understand how Linux file system works. So let me bring up a terminal. I have two terminals, I believe. Let me bring up this one. Okay, this is in the other workspace. Okay, so on Windows, you will have drives, things like C drive, D drive, E drive, F drive, as the case may be. On Linux, you don't do that. On Linux, we have root, which is represented as a /. So this / that's actually where all Linux the Linux file system begins from, that /. Okay, so we are going to go into that /, and to do that we use the cd / you hit your return button. So we are actually in that. Let me zoom in a bit. We are in the folder, root folder, if I will call it root. And it's root in the sense that it's the beginning of everything on Linux, but it's not root as in the home directory of the root user. We will come to that later on. Okay, so let's see what files and folders we can find here. Let's quickly look through. As you can see, we have a lot. We have a bin folder, CD-ROM, etc, intra, RD image. This is our Linux image, and of course, these two files you see here are used to boot your system. You don't alter them, you do, your system will not boot. So only alter them if you know what you're doing. Okay, so Keybase, this is a program I installed and the folder is here. You will not find that natively on any Linux system. Libraries, 64-bit libraries, normal libraries, lost and found, media. This is where we mount when you plug in the USB or any external device, it gets mounted to this folder. It will be given a name and it gets mounted to this folder. All right, so okay, so we will test that one out. Then we have the opt folder. That folder is used for installing third-party applications and some other stuff. Let me give you an example. If you were to install there's this popular program that we usually install, Bitnami. Yes, Bitnami is a company that creates a lot of packages, Apache packages, Nginx packages, and the rest of them. Now, if you install this on your Linux system, you will notice that the files and the folders will be found here. So as a developer for Linux, there are standard locations where whatever applications you're creating are expected to have their folders and their files, the binary files and the rest of them. I don't think I have anything. I think I have some stuff installed there. We will look at them. Then, of course, you have the root folder. That belongs to the root user. On Ubuntu, we don't activate or we don't use the root user account per se. On Red Hat, in Red Hat Linux, yes. On CentOS, yes. The root account is already activated. On Ubuntu, if you want to activate that account, you simply give it a password. You simply say password root. When you do that and you set the password, then that account becomes active. I have activated it on my own system because I think I used it for a few things, but normally you don't. So what you do on Ubuntu is that you have a program that is pre-installed, Sudo, and then you as the owner of the system gets added to Sudo. And so anything you want to do, that Sudo tool makes it possible for you to run that program as the root user. So you don't really need to become root per se or use the root account to run any operations on Ubuntu. You just need to be part of the Sudo group. And once you're part of that group, you need to just, once you need to run a process or do something that requires root privileges, you simply use the kind of, call it a prefix before the other commands, which is sudo. And when you run that, it will ask you for your password. And of course, it gets your password and it checks to see if you're part of the Sudo group as you claim. And if you are, then that process is allowed to go ahead. Okay, so we have the system binaries, we have the service folder, we have the system folder, we have the user folder, we have the var folder. This folder contains files that constantly change. That's where you have your log files, because these files are always changing as logs are written to these files. We will look briefly at them. We have the temp folder. This is my special folder. The temp folder is special in the sense that when I'm doing any stuff that I don't need the files to remain after I have done what I need to do, I run that process in the temp folder. I just create anything I create in the temp folder. If I don't add what is called a sticky bit to it, then that folder or file will be deleted at the next reboot of my system. So it's kind of where you keep things that you don't want to persist between reboots of your system, and then it helps you clean up your system. So if you want to do any stuff that maybe you want to do some demonstration or something, what you do is use the temp folder, do everything you want there. When you're through, you don't need to bother yourself. You simply just let it be. At the next reboot, it will clean up your temp folder and get rid of any files that are there that, of course, you have not told it to retain those files. There are some files in there, and those files persist because they have set the sticky bits on those files, and so for that reason, those files don't get deleted at every reboot. They remain there. Of course, the process folder and the rest. So let's quickly look at let's go back here. I had this opened. Let me go to Linux. let's come here. Let's look at this. Now, let's quickly run through this. Let me zoom in a bit. Okay, it's already zoomed in, but let's zoom in more. All right, so let's begin. It says, we here they're giving examples of what relative paths are and absolute paths are. Of course, this is an absolute path. This is also an absolute path. Now, like I told you before, on Linux, everything starts from a /. So if all right, let me open another terminal here. So okay, so let me zoom in. Sorry about that. Okay, so if I want to get to this folder using the absolute path, then I need to start that with a /. If you don't begin that path to the folder or file in question with a /, then that is taken to be a relative path. And of course, a relative path, I actually need to be in the same folder to have that happen. We'll run a small test to see that. Okay, so let me change into my temp folder. And of course, I had to use the /. Okay. All right. So that's my temp folder. Now, inside my temp folder, say I create, let me create make directory, make directory bin, and of course test. All right, we hit that. Okay, so the reason why I use this P here, this P says creates, of course, this make directory command will create this directory. And then this P option simply says if this the make directory creates this test folder, and then this P option here tells the command that if this parent directory isn't there, create it. So if I were to do that without the P option, it will error because it will tell me that the bin directory does not exist, you know, because I'm trying to create tests, but I passed in a parent directory called bin. So that bin directory has to be in existence before test can be created. So, but if I know it's not there, but I want to create a series of parent directories leading up to the current directory I'm trying to work on, then I pass in the -p option. When I do that, the make directory would look for a bin directory. If it doesn't exist, it creates it before creating a test directory. So let's change into those directories using a relative path and also using the absolute path. Now, if I do cd and hit enter, it takes me to my home directory. That is standard. Even on Windows, I think that's the same thing. cd without any options takes me to my home directory for me and not for any other user on my system. Okay, so now I want to change into that folder I created. Now, remember that we created these two folders inside the temp folder. So I need to pass /temp, then bin. Okay, hold on. It's searching through. I hit the tab. So it's going to search through the temp folder to see for any folder that has bi as the starting, two starting letters, and then it will now autocomplete. Okay, it depends. If your temp folder has a lot of files in it, then it will take a bit of time to search through. I think that's what it's trying to do. So let me leave it to do that while I open another tab. So I do change temp bin and then change bin and then I do what's the name, test, and I hit enter. Okay, let's see what happens. Okay, all right, so it stopped blinking here, but it's still searching. So this one hasn't given me control of the terminal yet because I cannot see this. Once I see this, I know I have control of the terminal. I can't see it here, so I don't have control of the terminal yet. Okay, so let's give that a bit of time to get through. It'll come back. Let's go down here. Okay, so you see here, this is an absolute path. This is a relative path because we don't have the /. And for you to use a relative path, you actually need to be in the same location with that folder to get to the relative path. Okay, so let's see if we are back. We are not yet back. Let's see this one. Still the same thing. Why is it taking forever? Okay, so maybe I would close this window. Would that be good? All right, let me close this and open a new window. Okay, let me close this and open a new window. All right, let me zoom in twice. Okay, so my system is doing a lot of work, kind of, so it's not responding the way I would have it respond. So just give us a minute or so. Okay, so let's look at another way to represent a relative path. You see this double period? That double period in Linux and of course Windows simply tells you that you should move one directory above your current location. And there you will find a folder called bin, and in that bin folder you will find a test folder. Okay, I hope this zoom is okay. Let me zoom in more. Okay, then there's another popular way you would find folders represented, the path to folders represented on Linux. You have this squiggly character here, and of course you have the / and of course the desktop. Now this here okay, this is not working out. Let me use the window. Right, let me use this. Let me open a new tab here. Okay, so let's give it a minute. So this character here represents several things. It is a short representation of home and username directory. Let me show you what I mean. This is not okay. Let me open my normal text editor, gedit, just as you have your notepad in Linux, but this gedit is extremely plain. It doesn't put in a lot of fancy stuff that notepad might put. Okay, so let me give us a minute. My system is doing a lot of work, but I'm running VLC and my OBS screen capture program. Okay, so here this squiggly character is the same thing as /home and George. George is the name of my home folder. It belongs to me, so it's named after my username, which is George. Now, if I were to do change directory, this squiggly character and all this, it will simply do what? It will go to this location. Let me bring that up. It will go to this location, home, GEORGE, George, and desktop. That is where it will go to. So instead of writing all of this, I will simply represent that by this squiggly character here. Okay. All right. So let's look at an example. Path names can contain almost any character, but some characters such as spaces must be escaped in most software, usually by enclosing them in quotation marks. So if you have a file that has a space in the name, you will need to enclose that file in quotation marks, open and close. Okay, that is in a way is escaping this, or you use a \. Okay, so let me show you what I mean by that. We still don't have this. Okay, that's a problem, but we'll see what we can do. All right, so let's go up here. I need to get my terminal working. Why is it not working? Let me go to the other workspace. Okay, this workspace. All right. Okay, so let's do what we saw there. Let me go into the temp folder. Okay, I'm in the location where I can find the temp folder. If I do list, you see the temp folder here. Okay, so I can simply do change T and it works. That's the relative path. Or I can do change CD, yes, temp, and it still works. That's because I'm in the same location with the temp folder. Okay, so let me clear the screen here. All right, so let me create a folder, a file that has, or a folder that has names in spaces in its name. So I'll use this. I would do, okay, 3 spaces, ginger. All right, and I touch that. I hope I will not cause issues here. Okay, so that's actually a file, not, okay, let me kill that. Okay, my system is acting up. Just give me a minute. I think I have this one also stuck. All right, let me go back to the first workspace and see if there are any improvements. There isn't, so I'm in trouble. Some things are just hanging. Go back to the other workspace and it's the same thing. Okay, so give me a sec. Okay, something is about happening. Cursor is no more blinking. Okay, so I actually was creating a file, not a folder. So I will need to delete that and create a folder. And I think I've caused. All right, come on. Do we not kill this? Okay. Okay, let me kill this. Let me kill this. Let me see this. Force quit. Force quit. Oh boy, today is gonna be crazy. Let me close these applications so that we can have. Let me close this one. Let me close this. Let me close this, close this. What's the problem? Force quit. It's not closing. Come on. All right, so okay, it didn't actually. There's a lot of issues here. I'm having a lot of issues. Let me open a new tab and see if I can get control of my terminal. Can get control of my terminal. Yes, I have control of my terminal, so let me zoom in. All right, so we have that. Let me see if that, okay, the application has, okay, has closed. Okay, so let's do that again. I was trying to do something. Let me go back to this workspace. Okay, so that has been closed. Let me delete that file if it was created. Okay. All right, so there it is. You see, this is actually the name of the file, and the space I kept here still exists here because I enclosed it in quotation marks, so it kept the space. So let me get rid of that. Let me get rid of that. So you see there, the system automatically escapes the 3 spaces I used with backslashes. So let me delete that. Okay, so let's create a folder. It should be make directory. This is what I'll call the folder. Okay, so now if we look at this, let's look here. See here, here we will actually, let's go into that folder. Let's see what errors. Let's use these 2 methods. The first one with enclosing quotation marks, and the second one with the backslash to escape the spaces. Okay, so let's go back here and that. And note, for one, if you create a new workspace, if you create, like I created this new one, so what happens is that the system automatically creates an empty workspace. So if you actually did two, it will add one more. That's just the way it's been configured. Okay, so let me go back here. Let's change into. All right, you see that the system immediately escapes that. So that's the second method. The first method, I could simply just do quotation marks. Okay, and that's it. And then we are in there. And so you want to know if you're in there, say pwd, and it tells you that. So that's how you can use spaces in the names of your files and folders. But I advise you not to, rather use underscores or hyphens if you need to have a space between two words that make up the name of a folder or a file. Now let's look at the main directories we have in a Linux system. Now the standard Ubuntu directory structure mostly follows the file system hierarchy standard. You need to look at that. It's extremely important. That's the standard that every Linux distribution is expected to follow. Many do follow, but some do still deviate from what is expected. So you will see slight differences between the different distributions on how they implement this standard. Okay, so we talked about the bin directory. It says a place mostly used for terminal commands. The boot contains files needed to start up your system, including the Linux kernel, a RAM disk image, a bootable bootloader configuration files. Okay, so let's just look at some of these folders. Let's see what's in there. So let's go into bin and list what is there. Now you can see we have tons. Now one will say, why do I need to use the terminal to get here? Okay, there's no problem. We could still use our file explorer Nautilus. So let's use the Nautilus file explorer, and let's use it to get to the bin directory. Okay, so we are here. Okay, so let me quickly come down here. The bin directory will be found in other locations, computer and bin. Okay, all right, so that's the same thing we saw when we did the ls. Now, the reason why I use a terminal is kind of quicker. Open it and, of course, change into it and all that. So this is how you get to the bin directory and the rest of them. Okay, so let's go back here. All right, so we have the bin directory. We have dev. Here you have your different devices. That's your hard disks and every other device that you have put in there. Just change into that directory and use the ls command and see what's in there. Then we have the etc directory. This is where every configuration file for the Linux system is situated. Every configuration file is found there. So if there's a configuration you want to change, it is found there in no other place in the system. It shouldn't be found in the bin directory. It shouldn't be found in the sbin directory, which is the system binary directory. This is where it is. I think this is one of this and this are the most visited places for me on my Linux system. Now the home directory. This contains the files and folders that belong to that particular user. Now I'm going to do a demonstration here where I will now share and use that opportunity to tell you what that home directory is all about. So let's see if I'll use a new workspace or let me use a new workspace. All right, so let's come here. Let me open a new terminal here. All right, let me zoom in. Okay, all right, let's zoom in a bit. All right, so let's see something. We have the home directory represented as like that, as we saw in that document. Now, what's the home directory? Let's change into the root section of the Linux system. Let's go here. You see the home directory? That home directory contains the home folders for every user on your system. Let's change into that directory. I don't need the / here because I am in the same directory as the home directory, which is /. and so I don't need to put a // but if you do, you will still get there. Okay, so we're in the home directory now. Let me do list. So I'm the only user on this system. I'm only user on this system, and my name is George, and normally a home directory will be created also called George, making it easy for you to find your home directory when you're working. So let's create a new user. In fact, let's go into the home directory George and see what's inside there. All right, let me do sorry, I made a mistake. Let me do this. Let me do ls long. Okay, so if you look carefully here, we have lots of files. These files belong to me, and I don't need to run use root privileges to work on these files because they belong to me. Okay, so so basically what we find in the home directory is folders that belong to each user on the system. Okay, so let me go back to where I came from. In Linux, if you want to go back to where you came from previously, you simply do cd space hyphen, and it takes you back there. So I'm back in the home directory, do list, and that's George. Now let's create a user. I think user add user. Okay. Now, because using sudo, in fact, because using the command add user, let me zoom that in. Let me make this a little bit, sorry, let me make this. Okay, because using the add user tool or program, you need to be, you need to have a root admin privileges. I will need to run that program with the sudo. So now the sudo is asking me for my password because it wants to confirm my identity. Okay, so I have entered the password, and on Linux, when entering the password, you don't see, you don't get any feedback from your terminal. You know, you don't get any feedback from the terminal. So if someone were to look over your shoulder, try and see if they can guess or try and understand how many characters your password has, they would not be able to do so because you won't get any visual feedback. So let me hit enter, and of course it starts creating a new user. It copies files. Now let's look at several things. It creates a group called Coco, just like the name of the user. You could change that too. We also have configuration files that you could tell. You could say, okay, don't use the same name with the name of the user. Use a different name. Of course, that will be up to you. Then that user is now added to the group Coco. Okay, so each user that is created on the Linux system is also added to a group with the same name as the user that was just created. So, and then the next thing it does, it creates a folder, home folder for, or home directory for the user Coco that still bears the name of the user I'm trying to add. And then it copies all the necessary files from what? etc/skeleton. That configuration files tells it the basic files it needs to add to every new user's home directory. Then next thing it does, it asks for the password. Okay, so I'm going to make it simple. Just going to make a simple password, and then password unchanged. Try again. Yes, I made a mistake, so it gives you, okay, so the name, I can put the name of the user, okay, and room number, whatever, work phone, all right, home phone, none. Okay, let's just add something there, and then any other, no other. Is it correct? Yes. And the user has been created, and the necessary folders have been created, and the user has been given a password, you know. So another way you could do it is you create that user and then allow the user to actually create their own password, so that even you don't know the password for that particular user. Okay, so let's see let's list the folders. You can see now we have created another folder which belongs to the new user. Okay, so let's go into that folder and see what is there. Let's list it out. All right, let's list and see even hidden files. All right, so you see here, let's look at several things. Let me seize the opportunity to explain several things. On Linux, this means current directory, this means parent directory, and this period before any name actually means that name or that file or folder is invisible, is hidden by default. So that's why when I ran ls the first time, these folders did not show up. This one and this one did not show up because they have a period before their name, and that period tells the system that those folders should be hidden by default. Of course, you could ask those folders to be shown by default, but you need to change that in your configurations found in your /etc file. Now, if you look carefully, this tells you, gives you a brief description of what kind of object you're working with and the permissions that are associated with that object and who actually owns or has various privileges and permissions to work with that object. Okay, let me go to bash here, bash rc. This is the configuration file that tells this terminal, this bash terminal, when it is opened by Coco, not by me. So if Coco wants his terminal to be green, he goes to period bash rc and sets it up there, and then when he launches his own terminal, it comes out green, but mine remains purple because it reads from my own configuration found in my own home directory or user directory. Now, if you look carefully here, this D tells us that this is actually a directory. And then this other one is a file. So it's a dash. So that's a file. And then in Linux, we have what we call, we have permissions. Of course, we have that in Windows too. So permissions normally have 432. Okay, hold on. Let me check that. I think it's 7 in total, so it should be 4. Okay, so let me come. I think I have okay, maximum permissions on Linux is 7. Okay, so we have several ways of representing that. We could represent them as a number. We could also represent them as letters. R here represents read, W is write, X is execute. Here you see this is for the owner, this is for the group, and this is for the every other person. So in a Linux system, there are 3 groups of people that can own a file. We have the owner of that file, the person who created that file. We now have the person who created that file, or the person who that file belongs to. Then we have the group. That group is the group that owns that file. Then we have every other user. So on Linux systems, you will often see where they will say change mod. You will see where they will say plus X or plus read. Now, this is simply adding read functionality. And of course, we have the other version of it, which will say 755. So that 755 means that the owner can do read, write, and execute. The group can only do read and write. And every other person too can only do read and write. That's 5. Okay. Okay, so now let's quickly look at something in Linux. Let me show you something. then we'll come back here. Okay, let's do it here. Let me clear the screen. Now in Linux, permissions are like 4, 2, 1. Total is 7. So for you to be able to read a file, write to a file, and execute a file. Execution here refers to changing into a file, changing out from, let's say, a file here. Remember I said also can be referencing a folder. And it could also be a binary file, could also be a program. So that is also executing. So for you to be able to do that, you need to have full permissions, which is a total of 7. Now, for what we saw earlier on, let me do this list and then show me the permissions. Okay. Now, in this case, okay, let me list out. Let me clear this. Let me list out all the files there and also the, oh, sorry, ls. All right. Now, oh, let me clear that screen and do this. All right. Now, here, if you see here, let's work with the bash. Okay. Now the bash here says this is the owner. His name is Coco, and this is the group that owns this file. You could actually have one owner, a particular user own a file, but a particular group, another group own that file. It's not a must that an owner of a file also has to be the same group. That no. But remember, when we create a user, it also creates a group with the same name as the user. And then it also creates the same, a group with the same name as the user. And then assigns by default, every group in that user's folder will be that group, of course. So here you see we have both Coco, we have both this. Both are the same, and we will come to understand that better. Okay. All right. So let's look at the permissions here. What can Coco, who is the owner of this file, what can he do? He can read from that file. He can write to it, but he cannot execute that file. That means I cannot do this. Okay. Bash logout. Okay, it's not even allowing me to do that because that file is not executable, so it won't even respond to auto completion. So I can't do this. Now, normally, if that file were a binary file and I wanted to run it, that's what I would do: a / full stop, the name of the file, and it will run. So this here is telling me that I can't, as the owner, run this file. I can't run it. Okay. All right. So I can only read it and write to it, but I can't run it. Then it says this group Coco can only read from that file. They can't even write to it. So if I wanted someone to actually be able to only read from a file, I'll just create a group, create a file, of course, create a group, and then add that group as the group that owns that file, and then give it the permission of only reading. Remember that you are authorized does not mean you are permitted. I say authenticated. That you're authenticated doesn't mean you are permitted. Yes, I am authenticated and the system knows it is me, but am I permitted to do certain things? No. So if I were to add a user to that group, the user is authenticated as someone who belongs to that group, but he is not permitted to write to that file. All he can do is read. Then every other person too can only read. So 4, 2, 1. Okay. Now I'm going to show you some tricks. Simple trick. Let me go. Okay. Let me do it here because I'll still delete this. Okay. So let's create a file. Let's do touch. Let's create me echo. Okay. In Linux, Linux doesn't really care about your file extension. So I could call this file .pz and it will still run any command, any bash script I put in it. So it doesn't matter. But by convention, we usually end it with sh. Okay. Another convention is to end it with .run. That's run. Okay. So when I see that sh, I know this file is a file that could be run. if the execution bit has been set, and if I see run, the same thing. So let me create a file here. Okay, permission denied. Now let me quickly share this. Now, as a system admin, there are some defaults that you will see when installing different Linux distros. Now on Ubuntu, when you create a new user, by default, I would have been able to do this, create a file in this Coco's home directory. But I changed that on my system and made it such that anytime a new user is created, only that user can create new files on their home directory, no other person. If I wanted to force this to happen, then I will use the sudo to create that file and it will happen. But the bad thing with that is that when you use sudo, that file itself will not be readable by even Coco. I think so. It will not be readable by Coco. So even Coco would not be able to work with that file. He will not even be able, or she will not be able to even delete the file because it was created using admin permissions. So he or she will need to, or the owner of that account will need to have the same level of permissions to be able to delete that file, write to it, or change anything. Okay, so in here let me switch to user Coco. Okay, su Coco. All right, I need to ask me for the password of Coco. Okay, I'm able to do this because I'm an admin. If you weren't in the sudo group on this system, you will not be able to change your change to another user. So here now I'm impersonating Coco, and if you see here, the prompt has changed. It was different here. It was George. Now it is Coco. Okay. All right. So I am now the user Coco. So if you want to know who you are, say, who am I? Coco. All right. So let me clear this up. Let me clear this up and then, oh, so sorry. You see, that's because CLS is an alias I created on my own .bash rc file. It's not present on Coco's own. And so Coco trying to use that CLS shortcut to clear the screen will not work. So let me use the proper one, which is that. Okay, so let me use the arrow key to flip through my commands. And of course, only the commands run by Coco will be seen because he can only read his own history file and not my own history file. Okay, so let me now do touch. My sha.sha. Okay, so let's list that out. You see that the file is there. Okay, so now let's open that file. Let me use the Vim editor. Let me use the shebang, use bin env bash. Okay, so we're going to do echo. My name is Coco. Let's do that. And then let's write the file first before we close it. Okay, so this line up here tells this environment bash that please you will use this set of libraries to run this command. If it were a Python script, I'll change this to Python. Okay, so you need to have this at the beginning of your script to have it run. Okay, so let me close this and let me try to run that file. Let's see the file again. Okay, to run, I will do, okay, it doesn't even respond to auto completion because full period and / is actually a way of running bash scripts on Linux, and because that bash script hasn't had its execution bit set, it will not run. Okay, let's see what we mean by that. Let's do list and see the privileges there. Now let's look at this. See that there's no X. So nobody, even the owner of this file, which is Coco, can actually run that file. Now let's change it so that Coco can run it, but members of the Coco group cannot run it as a binary file, as a bash script. Okay, so we do change mod, okay, and we do add X, okay, and we do this and hit that. Now let's look at that again. let's clear the screen. Okay, clear that, and then let's look at that again. Now, do you see? Oh, it actually did that for both the user and the group. Okay, so I added it for everyone. Okay, normally, okay, let me revert that. Let me do change mod. Okay, change mod minus X, sorry, not capital X. Let's see that again. All right, so it has removed the X. Okay, let's do that for only the user. So change mod, let's come back here, U plus X, hit enter. Now let's check that out again. What I simply did was add that execution bit for only the user. So even if you were a member of the Cocoa group, which by default Cocoa belongs to, you will not be able to execute that, run that bash script, because the reason why Cocoa is able to do it is because he's the owner, and that owner permission for executing that bash script has been set by Cocoa, but members of the Cocoa group don't have that same privilege. But let's check that out and see and be sure we did the right thing. Okay, there you are. You see there, it's now RXW. So only owner of this file, and of course you see the colors changed, can execute this file. But users who are members of the Cocoa group, which you see these permissions here, refer to them. So they can only read and write to this file, but they can't execute it. Then every other user, which is represented by A, or call it global, can only read the file. They can't even write to it, they can't even execute. So let's now do what we wanted to do. And you see now auto completion works, and boom, my name is Cocoa. So you see that? All right, so that's basically what happens when you're working in a group. So let's switch, let's exit here and go back to being George. So let's clear the screen and then list. Okay, let's go out of this, change, let's go one step up. So you see, this is basically how things are set up on Linux. On Windows, when you add a new user, of course, you have users and subdirect like that till the username and all that. In Linux, it's the other way around, or it's slightly different. In this case, we now have George, Cocoa. Those are the two users that are present on the Linux system. And of course, let us see how this can be done using the GUI. Using the GUI. Okay, let's see how this can be done using the GUI. Okay. All right, so let's see how this can be done using the GUI. Let's go to here. Let's click on settings. Now, most people think that everything is done in the terminal in Linux. No, it's not so. Okay, so Cocoa is already there. Okay, that's the user we created, and let us create a new user from here. Let me unlock, because you need to be an admin to be able to create a new user. So it's been unlocked, and then this unlock will last for a few minutes. After that, it is time-based permission. So after that time elapses, if you're not working, or either you're working, if that time elapses, then you will need to put in your password again. You can alter that time. You can tell the system, okay, anytime I use my password, please keep me authorized or permitted to run as an admin for the next 1 hour. It will do that. Ubuntu keeps you for a few minutes, and after that few minutes, if you try to do something after that, it simply just asks you for your password once again. Okay, so let's create a new user. Let's add a new user here. Is it going to be admin? No. Let me add Jane Man. Okay, and of course the username was automatically created for us. We could change this, Jane Man. Let's leave that. Do we set the password, or we let Jane do that? Let's set the password here. We'll set the password simply is Jane. Okay, and then confirm the password. It's complaining that the password is too easy. All right, let me see. Password needs to be longer, so it's enforcing this. Okay, it's forcing it. So let me see. Okay, so this you cannot just create. Okay, so it has permitted me. You can't just create any password using the GUI, but if it's in the terminal, it's very possible. So Jane 1 2 3 4 Jane. All right, so it should match. That has worked. Let's click add. All right, see Jane there. So this is the formation for this user. This is for Jane Man. This is for Coco. Okay, so let's see. Let's go back here and do ls. You see that a new directory, home directory, has been created for Jane. Okay. All right. So you want to delete. You want to delete Jane. You want to delete Jane. You can do that from the GUI. I think I closed the GUI. Let me open that up again. All right. So okay. So I can delete Jane from here. Remove user, or I can delete from here, the terminal. Let's delete this fellow from here. Delete, keep files. No, I want all the files to be removed. Okay, that is gone. Let's see if the file was truly removed. Okay, so Coco is gone. Now let's delete Jane from here. Delete user, Jane Man, and then let's say remove home. Okay, we want the home folder to be removed. All right, sorry, try again. My password is wrong. All right, so Jane has been removed. Let's see if the folder is still there. It's gone. So Jane home directory is gone. If you wanted to leave the directory, say you had a user on your system and you want to remove the user but keep their home directory, then you don't need to pass this option. It will keep their home directory so that perhaps you want to do some audits and the rest of them, you could do that. So that's basically what is there. Let's look at more of those directories. So this is our media directory. This one is once you plug in an external drive, it gets mounted here. So let's see what's in that. Let's see what's in that folder right now. So let me clear the screen here. Let me change into. Let me move one directory up. Remember, we're in the bin directory. So let me take it up one. And then I do media. It goes. Let's see what's there. So that's George. Let's see what's in George. Just do a list. So that's my Etisalat USB. Okay, that's my Etisalat USB. Okay, that's my Etisalat USB. It's been creating lots of folders, and I have one other folder here. So once you plug something, it appears here. So you could come here and do some manipulation from a terminal if you know what you're doing. Now, look at this special folder I told you about. Let's go into that folder and see. So I'm going to go one directory up. All right, so I have several programs that are installed here. TeamViewer, Sky, Zoom, and all that. That's standard locations for installing third-party tools on Linux. Okay, so on Ubuntu, other systems, other distributions also follow the same pattern. Okay, so once you install, let's say Zoom, and maybe you're trying to look for the files, you don't know where it is, simply go to the OPT folder and check there. You most likely will see it there. Okay, so that's where you find this. And of course, if you list, let me list that of Zoom. You see that all the libraries and everything that has to do with Zoom can be found there. Okay, all right. So in Linux, at times in Windows, you will have cases where you want to delete a folder, a program. It will go around searching for where it has installed these programs on your system and delete. In Linux, you simply, some programs that don't come with maybe an uninstall package or tool, what you do is simply come to the OPT section, look for that folder, and of course get rid of it. Okay, all right. So that's basically what we have for that. And of course, I will leave the link to that, to this location. And of course, you can come here and check and know what all these files, all these folders are used for. Let me move into the var folder. Let me go into the var folder and then let's see what is there. Okay, let's change let me bring this here. Let me change into var. Can do that. Okay, so let's list that. So we have the log files. In fact, var is where we keep where files are constantly changing in a var folder. Okay, so usually on some systems the var folder is usually given a large chunk of the partitions, and you would need to be careful so that it doesn't become filled up and the rest of them. Okay, so what else can we know about Linux? Let's go back to our Nautilus. Okay, so this is Nautilus once more. So let's go to documents. I want to create a folder. Yeah, this is a bit different, you know. Let me say I want to create a folder. I can do that. I want to create documents. Now you see these documents here. They are default documents that were set up by a program I installed. You can also set up your configuration to actually, I want to create a simple text file. You just do this. In Windows, I know it's a bit easier where you just right click and say create file. In Linux, no, it's not there by default. But if you wanted to create one, you simply just click here, open terminal in that location and do touch. Okay? And do a touch. Okay, and touch will now create it. Okay, so that's simple as that. All right, so we created something earlier. Okay, so let's look through. Okay, so if you look here, let me close this window. Don't need this. Close this. Okay, if you look down here, you see my taskbar kind of goes up and comes down. That's the way I set it up. I want it to disappear so that I have enough real estate. Now, if you want to do some basic settings, go to the settings page. Here you have for network, for Wi-Fi, for background, to change the background, your background colors and the rest. Appearance, you want lights, standard, dark. The icon size, you change it from here. Notifications, you can make changes here. Search, you can actually search search locations where when you run a search, where will be searched for the query item. Applications, notifications switched on or not. These are the different applications and the rest of them default applications, I believe. Then you have your colors. You have your users, like I showed you, default applications. Okay, these are the default applications that will normally open certain files with certain extensions. Okay, or certain contents. Date and time, you manipulate it here. About, tells you about your Ubuntu system. So basically this is this. Now this is for file manipulation. Now, let's do something. Let me quickly do something. Now let me close this. I made this a bit bigger. Let me close this. Now let me close this. Let me launch a new terminal. Okay, let me zoom in. Okay, let me click in there and zoom in. All right. Now, normally when you launch a terminal, the question is, where am I? Where has the system taken me to? You have been taken to your home folder, which we saw earlier. Remember I told you that this represents /home, the name of your home folder. Let's do pwd, which means present, is it present working directory? Hit that. That is it. So this squiggly here, or tilde as it's called, represents the whole of this. Okay? All right. So, but in Linux, in Ubuntu, if you want to get back to your home directory, you're lost, you don't know where you are, simply type cd, hit enter. It takes you back to your home directory. If you do ls, you see all your home directory files located there. So this is where we are. We want to go to our documents folder and create a new document. Let's clear the screen, change documents folder. I'll do this, which is the same thing as /home/George, and I did documents. Okay, and I'm there. If I do this, it comes out a lot of documents. Okay, now I want to create a document. I can do touch. Touch command simply creates that document, a document, and keeps it. It doesn't open it for editing. But if you want to create one and open it for editing, you simply just do, you could do VI, the name of the document, or you do nano, the name of the document, or you do emac. I'm not sure if emac is on my system, but let me use this to see. Okay, emac is not there. Okay, it's called emacs, not emacs. Okay, it's not there. Okay, emacs is another editing tool that you could use. I use Vim. We have gedit. You can also do gedit and the name of the document, and then it will open that document. And after that, depending on the editor you use, for Vim, if you don't save it, if you don't write to that file and you quit, it will not, it will delete that document you created. It will not persist the document. Let's use that. Let's do an example. Let me go to my temp folder where I usually would have things clear out after I'm through. Okay, so let me do Vim demo. Okay, it has created a folder. So that's the folder. I do, my name is George. All right, now I do this, and normally I would write to this file, but I just remembered I don't need this file anymore. I do this and I do quit, semicolon, and quit, hit enter. Override. I've changed the file, so I need to actually tell it ignore what I've written and don't persist that file. So I do this, the bang character, and then quit. And it, oh, I'm doing something wrong. Okay, Q then bang character. That's how it works. Now let's look for that file and see if we'll find it. I did demo, right? It's not there. Okay, but if I do this and I say my name is George, and I now do a write and then I close. Now if I do that grep again, it shows up. So that's why I like using the Vim editor. If I'm writing a file, you could write thousands of lines, and at the end of the day you discovered oh, I don't really need this file. So the next thing I would do is just a colon, Q, and the bang character. And once I do that, or exclamation mark character, once I do that, it will just delete everything I've written. That file will never be created, and so I don't need to do that. And I think Nano editor does the same thing, but I don't use Nano that much. That is how that one works. Okay, so that's for file manipulation on Linux. Then the other thing you need to do is programs. How do I get to a program? The first thing is here, show applications. Mine is at the bottom. I moved it there. Normally it should be at the top here. Okay, so here I see all my programs, and I can flip through and pick any one that pick any one I want to launch. Okay, so let me launch this one. Okay, so I just click on it to launch it. It did launch. Okay, it did launch it. Okay, so this is where we'll do our updates. So let's look at updates on Linux, on Ubuntu. So we have software updates. Now these are repositories. We have the main, we have the universe, we have restricted, we have multiverse. If you want the source code, of course, you click this. So some packages will be available in the main repository, some will not be. So I want packages both in the main universe, restricted, and multiverse. So at times you might search for a package and you try to install, it's not there. Most likely, most probably, you haven't enabled that repository, and so you cannot see that particular application. We have other softwares. You can click on this, updates. How do you want the updates to be done? Mine is daily, and the rest authentication. These are my keys. Additional drivers for any hardware. I might have developer options here, pre-release if I wanted that, but I don't. Then of course a live patch. This service makes it possible for you to keep your kernel up to date with live patches from Ubuntu or from Canonical. Okay, so this is this. Okay, if you want to do updates, there are several ways you can do that. You can do that in the terminal. And what updates do, I believe I have switched off my, I have switched off something. Let me close all this. Let me go back to the first one. I have switched off something that I shouldn't have. Let me close this one. Okay. Oh, it's strange. Okay, let me bring up my video again. Okay, so sorry about that. I think something happened. Let me put this here. All right, so let me always on top and always visible in every workspace and put it here. Okay, so let's we're talking about updates, I believe. Let me minimize this. Let me go back to, I think I was here. All right, so let's do some updates. Now, sudo apt updates. Now, this update doesn't actually update any application. It simply updates the information for updating applications. Okay? All right, so it updates your repository lists, so that when you now do upgrades and all that, it now brings in, if there's any new updates for any particular application, it brings that in and then does the installation. So you can do this here. And of course, some of us have noticed that you have seen these differences. We have apt and apt-get. Apt-get is the old package management tool, and then the new version is apt. We also have Debian Package Manager. This is what is actually called behind the scene by apt and apt-get. Okay, this is actually the main thing that is called behind the scene. Okay, so if there are two ways or several ways, I believe, in which you can update or install applications, but we'll come to that. So let's keep on the update part of it. Now, to update, you simply do sudo apt or apt-get update, and it goes. Okay, so if I do this, it asks me for a password because only an admin can do an update on a system, and it runs the update as it should. Okay, all right, so while that is happening, let us see how we can actually update from the GUI. Let's go to let's just type in updates. Okay, there you go, system updates. There you go. Okay, let's click on this. All right, let's give that a few minutes to show up. All right, so it's done its update. So you see it says get. I have not done any actual work there. Okay, so let me minimize this, or let me find this, and this is this. Okay, so you see that it's telling me that I've update software is available for this computer. Do you want to install it now? So I simply just updated my the information for my applications. I didn't actually install anything, and this is almost 1 gig. I can do this now, I can do it later. So this is how you use the GUI to update your system. And then if you want to do it from your terminal, you do it here. Okay, so if I wanted to actually do those installation, I usually do this sudo apt update, and if it is successful, I do sudo apt upgrade and then pass the Y option. Now that Y tells the system, don't ask me for confirmation when you are installing any updates on any of my applications. Just go ahead. I'm sure of what I'm doing. Go ahead. If you are new to this, it's advisable you don't put that Y option. And of course, if you are trying to do updates on your let's say Docker containers and the rest, you're running this a command there, then you need to pass that Y, because that Y option, because you will not have the opportunity to be prompted to say yes or no to your updates. Okay, so whether I should have this one run. Okay, I've already done updates, so I don't need to do it. Let me get rid of it and then hit that enter, and it starts. Okay, so we will leave that running and then we'll get back to that. Okay, so we have seen how to update applications. Okay, how do we install applications? Let me open a new terminal. Zoom in. Okay, how do we install applications? There are several ways to install applications. Let me go into my download folder and hope that I have Debian binary packages there that I can just show you a bit. Okay, so we have keybase AMD 64.deb. So that's a Debian file. Now, how will I work with that file? Okay, I have a zoom here. All right, so I have a zoom here. So this one was actually downloaded as you would download a Windows application file. Now, to install it, you could use the app tool, but in most cases you use the Debian package tool. Okay, so Debian package, pass in the I, and then you do zoom, and it goes to installing, for you. Okay, it does that for you. Now, another way you could install an application without having to download the binary, the archive or installation archive, as it were, is you use the let's search for zoom. Okay, let's do sudo apt search. You don't need that sudo there anyway. Search zoom. Okay, it's asking me for a password. I didn't need that, but let's see. All right, so we have zoom player, we have zoom service local installed. It's already installed. But if I didn't want, it is either I download that .deb file and use dpkg to install it, or I install it from here. So how would I install it from here? I will simply do sudo apt install zoom. Now, always search for a package you're not sure of by using the previous command I ran before you install. When you've seen the package and you know it's available, then you install. If you try to install it's not there, of course, it will error and tell you that package cannot be found. So I already have Zoom there, but to install it, this is what I would have done. So on Windows, you have to download the installation file and then run it, double click. In Ubuntu, you can also do that. You can also double click on the .deb file and it will open up the software center, and then from there you click on install. We will do that so that you will see how it works. Okay, so let me close this one because I'm already doing that in the background. It's still running 27%. Okay, so this is how I will install Zoom from my repository. Ubuntu Linux comes with repositories. Today we have things we call snaps. Snaps are an upgrade in the sense that a snap that can be installed on Red Hat can also be installed on Ubuntu. It's not specific on like a .deb file that cannot be installed on a Red Hat system. Okay, Red Hat systems use RPM files. Okay, so and that also cannot be installed here. So in this case, I would have just done apt install to install Zoom from the repository where Zoom is available, or I could just download the .deb file and use, of course, my installer package, which is dpkg, and then pass the I and then Zoom, and Zoom will work that out for me. And the Debian package tool will install that and of course do all that is necessary. Okay, all right, so that is how we install packages on Linux. So you either use you either use this file and this command, or you install from the repository directly by doing sudo apt install the name of the package you're trying to install. Okay, all right, so that is how we get things to be installed. That is how we get things to be updated on our Ubuntu system. Now, one thing I need to tell you is that I have not actually done a lot here, just at least the basics to get you to understand how to navigate around an Ubuntu system. And one thing you can be sure of, if you can navigate around an Ubuntu system, you'll be comfortable with navigating around a Red Hat system, a CentOS system, or any other Linux distro. Basically, the file system is the same. One thing I'm definitely sure is that every Linux system starts from /. So if you're lost, just type cd, enter, it takes you to your home directory. You want to know where you are, you type pwd, it tells you where you are. You want to create a file, you can do that in the GUI. You simply open the terminal in the GUI in that particular location, and then do your installation there. Okay, so let me leave this here for now. There's not much we can do. If there's any questions you have about how to use Linux and the rest of them, I'll be happy to take your questions. Just leave your likes and your comments in the comment sections below. Thank you for watching. Bye-bye.